Hey everybody, this is 4.10, and this section is very important. It's very useful, but with the advent of technology, it's actually become very simple to work with. What we need to understand is that we learned back in Algebra 1, and we even talked about it a little bit in this class, that when you have 2 points, let's say 3, 2, and 5, 6. That we can create a line that crosses those through those 2 points. And there's only one line that will cross through any 2 given points. No matter what we do, they will be simultaneous lines. If we end up claiming there are 2 different ones, we'll find out that they are exactly the same. And so, if we were to go and plot these 2 points, we know that there's only one line that goes through those 2 points. Just a second. Sorry about that. We know that there's going to be one line and only one line that goes through these 2 points. And it's a really crappy drawing, but imagine that went through the 2 points. Just make them a little bit bigger. All right, so 2 points, we're going to get a line that goes through them. And mathematically, that's really all that we can define. However, if we're talking about a quadratic, a quadratic could go through these 2 points. We could have a quadratic that looks kind of like this. Maybe that's the vertex. We could have a quadratic that looks like this. Something, oh, not quite there. But imagine, we could have different quadratics going through those 2 points. And so it becomes a little bit more challenging when we say we have a quadratic that we want to pass through specific points. It turns out, though, that in order to create a quadratic, all we need is a third point somewhere. It doesn't even have to be a symmetric third point. The mathematics of a quadratic, ax squared plus bx plus c, we'll do a y equals, are so sophisticated, so specific, that there is only one quadratic that will pass through 3 specific points. Now, traditionally, the way that this was done was through a system of equations. We learned back in chapter 3 how to do a 3x3 system. And if you can look at this equation, there's A, there's B, and there's C. That's 3 different unknowns. In order for us to solve and figure out what A, B, and C are, we would have to have 3 different equations and go through 3 different systems of equations. You guys remember that x plus 2y plus z equals 8. We'd have 3 of those, and we'd go through the elimination process to try and solve. We could still do that here, working for A, B, and C. However, with the advent of technology and how it's progressed along the way, the access to a TI-84 graphing calculator has made this so simple that there's really not a lot of effort being put into teaching it the traditional method. Happily go through that with you, but I also realize that most of you just want to be able to get the data and move forward. Scientists use this kind of calculation that we're going to do today all the time, and they do it as part of building models of predictability of the future. We want to know, where's our cells going to take us, or what's going to happen to the population of wolves in an area if we leave them, if we hunt them versus don't hunt them. Those kinds of questions are often solved using this kind of method that we're going to use today to build equations. And so the first thing we need to understand is you are going to need 3 points. Every time you need 3 points. And then we're going to use our TI-84 to do what's called a quadratic regression. That's going to build an equation that we could use to model anything in the future for this quadratic. So a couple things I want to show you just on the calculator, and then in the homework video you'll see me go through the actual calculations. But right here there's a button called Stat, okay, and we can edit the data. So we're going to hit Enter. If we put in some X's and some Y's, then we can make some calculations. And under Stat, in the term Calc, which is 1 to the right, we see a lot of different calculations. For instance, there's what's called linear regression. If I wanted to make a line equation, I could use number 4 to do that. Number 5 is called a quadreg, or quadratic regression. These others down here we'll learn a little bit about later in the next chapter. But here we're going to do quadreg. And notice it says my x's need to be in list 1, my y's need to be in list 2. But all I have to do is come down to calculate, and it'll spit out the data. That data then becomes my equation, which is super useful, again, for making predictions or understanding the behavior of a curve. If we know that a sales marketing campaign is going to cause a spike, but then it is going to drop off pretty dramatically, we want to know when is that going to happen? When do we need to reassess our campaigning, or our marketing campaign? Or maybe we know that we're hitting the bottom of the market, and we expect it to come back around. When is it going to hit the bottom? What predictions can we make about that? So those are important things that we try to understand and make use of every day. Good luck. Watch the homework video if you need some help. But at the same time, you have to remember we're using a TI-84. If you're going to use some other type of quadratic regression, I know you could Google quadreg calculators, and you can find ones that are online. The issue is making sure that you're comfortable the day of a test to use the tools that we have. If not, we can learn how to do it by hand. And I know most of you would want to cry if we had to do that. But anyway, I'll see you guys in class.